For electric current, there's one guy we got to give credit to, put it all together. This is what he looks like. His name is George Simon Ohm. He came up with Ohm's law. Ohm's law, the trick is you draw a triangle, okay? It's a little algebra trick. I don't know if you guys have ever seen this in algebra. It's called the triangle trick. You put V on top, I on the left, R on the right. This actually works for any algebraic equation, but for Ohm's law, it's particularly effective, okay? Anyone want to take a guess what V stands for really quick? V is for voltage. You guys remember that? Okay. The units are volts for voltage, named after Alessandro Volta. What is a volt? It's energy per charge, potential energy given to every coulomb of charge. Most people are like, what the heck is that? I don't get it. Here's all you care about. You just care about getting the right battery, the juice to get the job done. A D-cell battery is 1.5 volts. What does that mean? It means that for every coulomb of charge, Q is for charge, you get 1.5 joules of energy. Still doesn't make any sense. Use the analogy of gravity. Here's my little toy. When I turn it on, the little seals go up the stairs. Okay? Then they get to the top of the hill, and then they can ski down that hill. Yay! Okay? They can ski or sled down that hill. That's a great analogy. That's what a battery does. It lifts charges to a higher electric potential, and then those charges can flow down through that circuit and do work. Okay? So think of that as what a battery does. It's a pump, but it's an electrical pump. It pumps up charges to a higher electric potential. I, take a guess what I is for. I is for electric current. And you might say, well, why not C? Shouldn't C be for current? Okay, good question. C is already for coulombs of charge. We run out of letters, okay? I is for current, which is measured in amps or amperes, okay? Named after this French scientist named Ampere. And I, for current, is equal to Q, charge, divided by time. It's how many coulombs of charge flow by every second. So what would that analogy be? I could take a stopwatch, turn on my circuit again, okay? Wait till the charges get to the top of the hill. There we go. Good enough. And then I would time in 1 second how many charges flow by, okay? Actually, this thing is getting kind of annoying. There we go. And if, let's say, 3 charges flow by every second, that would be 3 coulombs per second. That would be a 3-amp circuit. If 5 flew by, it would be 5 amps. If 10, it'd be 10 amps, etc. Okay? Finally, R. What do you think R stands for? R is for resistance, okay? R is for resistance. The units for resistance is ohms, named after George Simon Ohm, a Dutch scientist, I believe. And the symbol we use is the Greek letter omega. It looks like a horseshoe, okay? Which I didn't draw very well. There you go. It's the Greek letter omega. If you ever get hungry at 2 in the morning, you could go to Denny's, but you could also go on Ogden towards Downers Grove. There's a Greek restaurant named Omega's. That's what the symbol looks like. Yeah, it's fun, right? Way better than Denny's. Great omelets at 2 in the morning, steak and eggs, milkshakes. Just watch out for police. They like to get you guys on Ogden, okay? So anyway, why the triangle? Here's a little trick. If you want to know what each quantity is, you just cover it up. So if I want to know what V is, cover up the V. If I cover up V, V is equal to, on the bottom, I times R. You guys see that? Cover up the V, you get I times R. Okay? What does that mean? It means voltage is equal to current times resistance. How about I? What would I be equal to? If I cover up the I is equal to what? V divided by R. And then if I cover up R, what is R equal to? V divided by I, okay? These are the 3 forms for Ohm's law. Probably out of the 3, put a box around number 2, the second version. This one probably is the one that makes the most sense intuitively. Why? Because if you think about it, I is like the flow of water, the current flowing. V is for voltage, R is for resistance. So let's use common sense. Which would give me more electrical current in a circuit? 1 battery or 2 batteries? Yeah! Which one? Obviously. 2 batteries, because 2 batteries is twice the voltage, twice the energy, twice the electric pressure, twice the potential, twice as much current's flowing. What would give me more electric current flowing? A 5 ohm resistor or a 10 ohm resistor? Which one would allow more current to flow? The 5 ohm resistor, right? Because it has half the resistance. So if you think about it, the amount of water flowing, I could turn on the sink up here, but that would be bad. There's all these electrical cables, right? Depends on how much water pressure, that's like voltage, and then resistance. That would be like turning the knob there, okay? That's the one that probably makes sense out of the 3. So there's different ways you can look at this, okay? A volt you could think of as how many amps times ohms you have flowing, or resistance is how many volts it takes to let 1 amp flow, is another way to look at it. Okay? Either way, these are the 3 big quantities when it comes to electrical currents and circuits. This is the equation we'll be working with in this unit, okay, to understand how circuits work. So in a nutshell, we just want to go over Ohm's law and then the basic definitions reviewing for voltage and current, okay? If you want to, get a tattoo and put it on your arm for this unit, a little Ohm's law tattoo there, little triangle, okay?